embarrassing for you? Okay. So here we go. We are heading into logs, but not quite today. Because today we're doing something much easier. And we're doing a thing called the law of exponents. And you do not need to write it down. It is the easiest rule in math that we have. I'm going to show it to you right here. And the law of exponents says this. If you have two things, one thing on one side, one thing on the other, and they have the same basis, then their exponents have to be the same. And you're like, what? And let me show it to you. Oh my God. If I have, I'm going to change that in a minute. If I have 5 to the third equals 5 to the x, the bases are the same, then x has to be 3. There's nothing else it can be because they are the same. But there are a few things that make this a little tricky. Thing number one, Jax is watching me. Thing number one, the bases have to be the same. Tomorrow and moving forward, we will change these to different bases, and we use a different technique. And you know what we use? We use logs, right? But today we're going to use the same base. So trick number one is we have to have the bases be the same, and sometimes they won't. But we're going to force that to happen. Second thing is we can only do this if we have one thing on one side and one thing on the other. So we may have to squish some stuff together. This is the lightest work we do in this chapter. We've got 6 examples. Get your whiteboard pens out. Here we go. These are they're gonna go fast. I'll be done in like 10 minutes. Here we go. First one. You should be almost able to do this in your head. I want to be really clear on this. We don't really cancel the bases. If you say that to a teacher in college or a teacher is teaching an AP class next year, oh, you cancel the bases, they will get mad at me. We can ignore the bases if they're the same and if there's one on one side, one on the other, but we can't really cancel them. We are ignoring them. Here we go. X equals 5, light work. The math is easy today. Here comes the next one. Are you ready?
Wait, seriously?
Yeah?
Actually?
You know what? But then the next one you're gonna like. It's a little fun. It's not horrible. I'm sorry. So here's my problem. My bases aren't the same. So guess what? On all of these tonight, make them the same. Take the big guy and turn it into the little guy with an exponent.
I do square notice.
About 5 squared. So you're going to say this first part is this equals 5 squared. And then the bases are the same, and we can ignore them. Here's what it is. We're going to rewrite that as 5 squared. Are my bases the same now? Yes, they are. Can I ignore them? Yes, I can. And do I get 2x minus 4 equals 2? I do. If I get x equals 3, yep, you got to do that basic math right. Okay, gonna get a little weirder. Here we go. Ooh, First thing, I don't like 9. I'm gonna turn it into a 3. So can you rewrite this fraction as 1 over 3 to the something? Right? Nice and easy. So we're saying, hey, dude, I want you to look at least like a 3. You're not really a 3. And then Colton knows what's happening. He's in the denominator. He's in the basement. I don't want him in the basement. I want him upstairs with us. Well, he doesn't want to be there. And so he's going to come up, but he's going to have a really bad attitude. He's going to be very, very negative. Yeah, you see where I was going with that? So guess what we're going to do? We're going to say 3 to the 2x plus 1, or 3, sorry, equals 2, equals 3 to the negative 2. Can I ignore the bases now? We can. I am adding in a weird one real quick. I didn't do this in the other classes, and then I had to do it later. How about this? Ooh, what about that one? My base is 7, but my other number is 0. No, no, not 0. Changing it, changing it. How about my other number is this? 1. 1 is the first, that's not going to help. How can I change any number in the entire world into the number 1? Any number. Use the 0. Make it 7 to the 0 power. See where I messed up on putting that there? So anytime I see a 1 is complete, it's like a little chameleon. It can change into anything. It's like a little shapeshifter. Can I make it into a 7? Sure. 7 to the 0. Could I make it into a 25? Sure. 25 to the 0. 1 is our chameleon number. We love that for him. So if you got 2 on this, you are fired. Okay, here comes a weird one. Are we ready? Now, we need to talk about this one because you are all going to blow this problem if we don't talk about it. So ladies, smart ladies over here, I need you to watch me. And that's fine. Ladies, we'll take any of them. Here's what. You know how to do this, but you're going to mess up, and I'm going to show you why. I'm going to move this over. Does anyone have a hard time doing that problem right there? Slight work, right? It would be what? X to the 6. Nope. X to the 5. X to the 5. We don't change the x. We just add the exponents. Nice and easy. Super light work. But watch what happens when I do the exact same problem. You all want to make that into 4. But I don't want to make that into 4. If the x stays the same, the 2 is going to stay the same. I know we are compelled to make this 4 to the 5th. That's not right. Changing the exponents deals with it. So this guy is not going to turn into 4. It is going to turn into 2 to the 5th. So with that said, I would now like you lambs. Oops, get out of here, dude. I want you guys to do this. Here's what I want you to do. Put those together. Put them together. All you're doing is you take your base and add your exponents. When you're multiplying, you take your base and add your exponents. We're not going to multiply those 4s together because the exponents take care of that. That's it. Yeah, 2x plus x minus 3. Oh, sorry, 2x plus x minus 3 equals 12. Oh my God, welcome to school. Did you get like 5? X equals 5? I got 3x minus 3. Are you good with that, Topher? Am I cool? There you go. So 15 divided by 3. Yeah. Okay, I think we got 2 more to do. Same problem as the last 2. We got a first thing, that guy's in the basement. Don't have your numbers live in the basement. That's sad. Bring them upstairs. Will they be negative when you do it? Sure. But that's okay. And rewrite your 25 as 5 squared squared. Think about that. I love this problem. So remember, it's 5. Oh, good. Yep.
4.
Yes. Nice. I think it's a stupid number, like 7/2, something like that.
Yeah.
Where'd you get it? Nice.
4 and 7/2. Thanks you, sir.
Okay. So I'm taking him. It's going to be learning. Coming together. Put all this away. Do this now. Show this class. Do this class. Do this later.
Yes. Look how I pulled it close.
You're on your. This is the start table. Okay, move on. I'm upstairs. So move on upstairs. So put it down.
So look, I woke up today, turned my alarm off just at 6. My mom could give me my room. And if I leave this little sick kid, I could go to school. Right. Look at this here.
Oh, there's a few minutes here, are ya? Boston squared. Boston squared, here we go. 5 to the 2x times 5 to the negative 3 equals 5 squared squared. So here's what I got. I can ignore, I'm going to put these guys together. 5, 2x minus 3 equals 5 to the 4th. Now I can ignore my bases. 2x minus 3 equals 4. 2x equals 7 over 2. 7 over 2. Are we okay? Last one, best one. I'm going to hand out the homework while you're doing it. I will give you a hint. You might have to do a little bit of distribution when you write that as 4 squared. 4 squared to the x plus 1. A little bit of distribution on this guy. A little bit of distribution on the, I mean, not distribution, just multiplying. We multiply our exponents when we raise them to a power. This is our last one. You write that 16. If you are at home listening to this, your homework is out of 13 problems. Do 8 out of the 13. Cross off 5. Do ones on the back. Don't be a baby. Bye.